Hello, let's look at factoring trinomials next. Basically here we're going to be trying to unfoil. So if you think about when we were reviewing our distributive property, if we had something like x plus 2, x minus 3, when you FOIL that out, you would end up with an x squared minus x minus 6, very similar to the sort of thing we have here, where you have a squared term, a term with your variable to the first power, and a term without a variable. So we're hoping that we can reverse what I just did, the multiplying out. And it's much easier in a situation where the number out in front of your squared variable is a 1. So if you just have a 1 times t squared, you don't have to worry about any coefficients. You get for free that you need to split that up equally and have a t and a t. So now when we multiply the first two, we've got the t squared. Done. The thing that's trickier about the last two is that yes, we need the last two to multiply together to give us negative 12, but we also need the last two to help us get the negative 4t in the middle. So when we choose these factors, basically we need them to multiply to be negative 12, so the product is negative 12, and we need them to add up to negative 4. So you can start thinking about factors of negative 12, so it would be like a 1 times 12, and one of them gets to be negative, a 2 times 6, a 3 times 4, and for starters, let's just think about if the first one is negative. The deal is, if you end up with a 4 instead of a negative 4, you just flip-flop the sign. So as long as you can get the number right, it's very easy to switch it from a positive to a negative. If I add up negative 1 and 12, I get 11, which is nowhere close to 4 or negative 4. So I'm going to say no good there. If I add up negative 2 and 6, that's looking promising. I get positive 4. Again, if the sign is wrong, all you have to do is switch which one is negative. 2 plus negative 6 will give me negative 4. I keep erasing extra pieces. And just for the sake of checking every one of them, if you add up negative 3 and 4, you get a 1. Doesn't matter if I fix the sign or not, that's no good. So it's going to be a 2 and a negative 6, so plus 2 minus 6. I highly encourage you to double check yourself at least some of these by multiplying it back out. If I FOIL that out, so this is my check, I get a t squared. The outside is negative 6t, the inside is 2t, and the last is negative 12. So again, the negative 12 is good. We plan that carefully with the product part of our statement. The tricky part that you have to just get good at checking for yourself is, did I get the inside outside right? So negative 6t plus 2t is in fact negative 4t. So I got all of it right, which means my answer is the factored form right there. Okay, so all fine and good when the leading coefficient is 1. It gets a little trickier when the leading coefficient is not 1, which is what I've got going on here. Let's switch colors. I also have a funny order here, which sometimes really stresses people out, but it actually doesn't much matter. You can absolutely split this out so that your m's will be in the last two instead of in the first two. So here's where trial and error can get a little trickier. I really encourage you to try it, and then I'll give you another method for if you're getting stuck. Right now I need factors of negative 6. So my choices are a 6 and a 1, or a 2 and a 3. And again, something gets a negative sign. That's fairly easy to fix later. So since this is the first step on this, I'm just going to pick a pair, and then I'll do a little trial and error to get the 4 right. So let's say we want, I don't know, the 2 and the 3. That's what we're thinking. And don't get too worried about a sign. Throw one in somewhere. I had it here, so we'll try that out. So this is going to be a plus. This is our first guess. Now we also have to split up factors of 4. So we get a 1 and a 4 or a 2 and a 2. And here we could say both positive or both negative. I'm going to say both positive because we can always fix the sign by switching the 2m and the 3m around. So let's just throw one in. Let's throw in 1 and 4 since that's first on my list. and we can check out what's happening. So 1 times 4, that matches up with the 4 that we have. Negative 2m times 3m matches up with the negative 6. The big check is the negative 2m. That's the inside plus the outside. Doesn't matter which order you check those. So we have a 3m minus an 8m. That is not negative 2. So this pair did not work. We could try, I guess I may be getting a little ahead of myself. There's one more thing we could try. We could try switching the 4 and the 1. So now my outside inside is 3 times 4, 12m minus 2m. Not even close. I get 10m. It doesn't matter if I fix the sign there. That's not going to give me negative 2. So now I think it's fair for me to say 1 and 4 is no good. Let's instead try the 2 and 2. And here's where factoring can get really frustrating. If that fails, we'll have to go back and try the 6 and 1 instead of the negative 2 and 3 or 3 and 2 and negative 3, whichever way you want to do those signs. So if I do 2 and 2, I get 6m minus 4m. That's pretty good. That's 2m, but I wanted a negative 2m. So all you have to do to get that sign swap is to switch both of these. You're not allowed to switch just one because that'll mess up either your first or your last, but that will do it. Okay, so if you're really beating your head against the wall on one of these and getting frustrated, there is a little bit of a trick like we did for the first one that you can use on these. And it forces you to go back to some grouping, but it's better than getting completely stuck and just going nuts trying to do these. It is really very similar, but instead of just looking at the constant, just looking at the negative 12 is what we did up above, what you're going to have to do to make this work is look at the product of the constant and the leading coefficient, including that negative sign. So we need factors of 6 times 4, negative 6 times 4, so negative 24. We need factors of 24 that sum to add up to negative 2. So your factors of 24 are 1 times 24, we can worry about signs in a minute, 2 times 12, and 3 times 8, oh my goodness, my brain broke for a minute, and 4 times 6, and I think that we're going to start repeating ourselves after that. Okay, so we can just throw the negative out on the first one, and then if we get the right number but the wrong side, so if we get a positive 2, we'll just switch where the negative is. Negative 1 plus 24, absolutely not, that's 23, nowhere close to 2. Negative 2 plus 12, that's 10, no good. Negative 3 plus 8 is 5, closer but still no good. It's negative 4 times 6 that's looking promising. That adds up to positive 2. I really would like a negative 2, so I'm going to make that a negative 6. Here's the catch. Here, let's do this one in a different color as well. We can't just then go and say, okay, those last two numbers need to be 4 and 6. What we have to do is split up that negative 2m in the middle. So we say, okay, we're going to break that up and say that should be a 4m minus a 6m. And this should work no matter which order you pick for those two. In this one, I think the order I picked is going to be particularly nice, but it will still work even if you pick the opposite order. It just changes which factor you find first is kind of how I think about it. So now we have to factor by grouping. If we group the first two, I can factor out a 4, and I'm left with 1 plus m. If we group the last two, I can factor out a negative 6, and it has to be negative. Oh, hold on. A negative 6m. And I'll be left with a 1 plus m. That last one is a little tricky. Remember, the easiest way to double check yourself would be to distribute it back in. Negative 6m times m is negative 6m squared. If you're not getting back that negative 6m squared, then you've got a mistake. And then your final step here, so you can see it's a little slower, but it does give you some definite steps to follow if you're not succeeding with your guess and check. So I can factor a 1 minus m out of each of those. This is the split between the two terms. So if I factor 1 minus m out before that minus sign, I'm left with a 4. This doesn't need to be a square bracket. I'm just doing that to really show where I'm splitting this off. And then if I factor a 1 plus m out after that minus sign, I'm left with a negative 6m. And that's factored. It's actually not fully factored, which makes me realize something that I did that made our life a little bit harder. We could factor a 2 out. I'm going to put it all the way out in front, but I'm taking it out of the last set of parentheses. And we'll be left with a 1 plus m and a 2 minus 3m. If you end up with a greatest common factor at the end, what happened was you had a greatest common factor right at the beginning. And this would have been a little bit easier if I had recognized that from square one. But I'm actually going to leave it. I think that's kind of a good lesson. I know I have more greatest common factors coming, so I'll be careful to look for them in the future. Okay, let's try again with 16y squared minus 24y plus 9. My first reaction is I don't love how big those numbers are, especially since they also have quite a few factors. That always makes it harder. But we can go for it. We can try. As I forgot last time, I'm going to check this time if there is any common factor that I can factor out of this. It's not looking very promising, though. The factors of 16 are all even. We could go like 2 times 8. We can break it all the way down. 2 times 2 times 2 times 2. The factors of 9 are 3 times 3. So there's nothing that I'm going to be able to factor out of that, and there's not a y in that last term. So if we want to try the trick I was just talking about, we need 9 times 16, which ends up being 144, which can be kind of a daunting looking number. And it does actually have quite a few factors, but we can start to eliminate really easily. We need them to add up to negative 24. So we're going to need 2 of the same sign to get a positive 144. So we need 2 negatives. So we could do negative 1 times negative 144. There's no way that's going to add up to negative 24. We could try dividing out a 2. Negative 2 times negative, what would that make it? 72? Basically, what we need is to get 2 factors a lot closer together, and what maybe some of you are kind of screaming out at this thing if you have your perfect squares memorized is that 144 is a perfect square. It is 12 squared, so that leads me finally to what actually looks pretty promising, negative 12 times negative 12. So if we're going to go about factoring this way, and I will show you one other thing that I noticed as another option, we would split this up, negative 12y minus 12y plus 9. We can factor, what can we get, a 4y out of the first pair, and we're left with 4y minus 3. We can factor a negative 3, and it has to be negative. If there's a negative out in front, you're stuck factoring the negative out as well. And that would leave us with 4y, and then 9 divided by 3 is negative 3 again, which is promising. We can factor out that 4y minus 3, and we're actually left with a 4y, this one, minus a 3, this one. And it turns out that we have a perfect square trinomial. So what I was going to point out is that if you're watching for it, sometimes you can spot that right away. The fact that this is a perfect square and the 9 is also a perfect square, if you see that, you might just go straight for trying this. Try and make the 2 factors identical. That's kind of a neat one that crops up sometimes. But if not, we got there. It was just a little bit tedious with a little bit bigger numbers, so you can always use a calculator to help you check for factors. One last one, just to get a few good examples in for you. I definitely see a common factor here. I can divide a y squared out of everything without making any fractions, and I can also divide out at least a 2. That might be about it. I think I get a 2 out of that. If I divide the 8y to the 4th by 2y squared, that leaves me with a 4 and a y squared. So the division is maybe the way to try and think about it, but your check would be if I distribute that back in, do I get 8y to the 4th? The multiplication is much easier to check than the division is for a lot of people. And then we'll need a minus. 24 divided by 2 is 12, and y cubed divided by y squared leaves me one single y. And then we get a plus. 18 divided by 2 is 9. Y squared divided by y squared doesn't leave me any y's in there, so just the 9. Okay, so I have 2y squared, and then I'm going to work on in the parentheses again. Although it is jumping out at me, I see some perfect squares, but we'll still try it the other way. If you spot that, you can try that right away. 9 times 4 is 36, so we take the first and the last there, the leading coefficient and the constant. We need factors of 36 that add up to negative 12. So again, you can just make your list and start going through if you want to. They will both have to be negative. Negative 1 and 36 is not going to get me anywhere close to negative 12. Negative 2 and 18. Closer, I'm at negative 20, still not there. Negative 3 times 13. Negative 13 is negative 19, still getting closer. Negative 4 times negative 9. Is negative 13, getting really close. And then the next one, I think we'll do it. Negative 6 times negative 6 does give me positive 36. And when I add those up, I do get negative 12. So if we're doing the grouping method, again, if you spot it, and you can go straight to the 4y minus 3, 4y minus 3, beautiful. If not, what I'm showing you off to the side is your method for getting unstuck. So we'll do a minus 6y minus 6y. You split up that middle term. And then we need to group. Out of the first two, I'm going to do a square bracket so I can keep track of this. I can factor out a 2y. I will be left with a 2y minus 3. Out of the next two, I can factor out a negative 3. And I'm also left with a 2y minus 3. Again, to check that, just distribute back through to make sure that you're right. Which lets me go one step further. I have the 2y squared. Inside those parentheses, I factored out a 2y minus 3. The separation is right here. So if I take out this 2y minus 3 and this 2y minus 3, I'm left with the 2y out in front and the minus 3. And then again, you can regroup. Let's see if I can fit it. 2y squared times 2y minus 3 squared. So I gave you two perfect squares. They're not super common, but they're kind of neat to watch for. Okay, so hopefully that helps. If you're having trouble and you need some more examples on factoring, that's an easy one to find on YouTube, or I'm totally happy to track some down for you as well. This is a skill that's going to get used all quarter long, constantly. So really give it some attention now. It's going to make everything so much easier for the rest of the quarter.